Welcome back to the Geometric View, episode 84, season 7. This is the last episode in this season, and we will be changing it into season 8. Today we have Lori Gardi, aka Fractal Woman, and we go over some of her content in a disclosed manner, sort of a secret conversation. So the 2022 Electromagnetic Universe World Expo was amazing. We'll be releasing the
link is in the show notes below
on this channel.
Let's get into the circuit.
The Geometric
We
View.
appreciate your support. The best way to donate to us is on PayPal. Just send money directly to goldenscaling@gmail.com. Thank you very much.
Then the water is moving. Then you get the particle, the particles of water then are in motion. You get the inertia, you get the momentum of the water molecules. You can surf on a wave that's crashing. You can't surf on a wave that's not crashing. You can only surf on a wave that's crashing. So only when a wave is crashing do you get the particle-like phenomenon. And so it's once you break the wave, then you get the particles. So that's sort of wave-particle duality right there. And I was able to get my boss to admit that, yes, it's only a particle when it enters the detector, when it crashes into the shore of the detector.
Correct.
So
when
it's
becomes
propagating
a
its
load.
wave.
Right.
And that's exactly it. When the electric wave crashes into the load, that's when work gets done.
Yes, that's exactly
circuit.
Correct. And it has, and they call it intensity, but it's still just another way of saying
intensity is a better word.
Yeah.
Intensity is a better word. Intensity has units watts per meter squared. So intensity is power over a surface.
That's
right? So you need to, right? And so like people don't, like I'm a big fan of unit analysis. I study it. I developed my own called modified unit analysis. And you have to look at the units. People forget. They equate intensity with energy, but intensity is watts per meter squared. It's not energy. And so, all the black body experiments done back in the day were reported in terms of intensity, in terms of power, watts per meter squared. And so, but they ended up writing an energy equation, E equals HV equals H times frequency, Planck's constant times frequency. They wrote the equation in terms of energy, even though the phenomenon they were reporting on was reported in terms of power. So they made a mistake. Like my boss won't admit 100%. That was a mistake.
Well,
he won't admit it's a mistake.
It's hard to admit because the bifurcation of cosmology in 1927. Speaking of which, what I've done here, I shared first of all my op-ed about light, that photons cannot possibly be particles, and then I also shared my peer review of Stephen Crothers, who personally told me that after reading my peer review of his research that I understood the mathematics, and he's a pure mathematician.
Good.
I had him on my show.
Good.
He assures you that there is definitely a problem with general relativity. Yeah. I don't have a problem personally.
No,
with
there's
special
a problem.
relativity.
Okay, the equation they use, the square root of 1 minus v squared over c squared. There's nothing wrong with that.
Correct.
So that's all. There's not, and Einstein kind of stole that from Lorentz. That one is fine.
Correct.
I actually found that. I found it somewhere else, so it's correct. But all the other gobbledygook, it's bullshit.
Well, he got, and in one of my papers, I have a list of chronology of things, and Henri Poincaré came up with many of these concepts, gravity waves and relativity, before. The mass energy equivalence was before Einstein. What he got his Nobel Prize for is pure. His work with Bose, of course, Bose deserves most of the credit. That's pure. Yeah. But as soon as he got stuck on gravity and Big Bang, he just fell down a hole. But that's okay. It can happen to anybody. It's happened to many. It happened to Kirchhoff.
Lori,
So,
just because the math works doesn't mean it's same as these computer models. You program into what you want to see, and you get what you want to see. Math is the exact same thing. It's just a tool. You can't you can't use math to prove anything beyond 100%. Like you cannot. It can be used to help add evidence to your theory, but a lot too many people put way too much in put math on the pedestal and say, oh, it must be true.
Exactly.
But
You're
it's not.
You're 100%.
And I had when you said that Einstein was right about relativity, I cringed.
No. I said Einstein was
You mean
right
special
about
relativity.
just 1 minus the square root of v squared over c squared.
Yeah, she's talking about
that
special
is
relativity.
that works. That's correct. And actually, in terms of the mass increase in time dilation, clock retardation, and
that's special relativity.
Yeah, and I found that in my model, so I believe that it is correct. The mass increase is not a real mass increase. It's intrinsic mass. It's really a momentum increase. Obviously, when you shoot a ball faster, it's going to hit the wall harder. That's all it's saying, right?
You might find this interesting. A couple of months ago, I don't remember exactly which month it was, I did an analysis and replaced various types of Newtonian masses with charge. At the end of it, I came up with a distance, which I'm calling curvature in honor of Gauss. And it replaced the constant, the k.
Okay.
And the distance came out to the order of 10 to the minus 60, below the Planck length.
I know what that is.
Tell us.
That is the quantum of charge.
Okay.
I get the same value. I get the same value, around 10 to the minus 60. Somewhere like there's a couple of ways of calculating it, but I found the same value, and I call it the quantum of charge. But it is if you take Planck's constant. So I have a bunch of constants. If you take Planck's constant and divide it by the speed of light, you get the quantum of momentum. When you take that and divide it by the speed of light, you get the quantum of mass. And when you take that and divide it by the speed of light, you get the number that you just reported. Which is
interesting. So it'd be interesting to see that, and then show them parallel, because they were obviously done with different methods, and show that there's a basis for this K curvature, because I think that it's the resolution that we really need if we're going to really see anything. This is much further down than strings and all that other stuff that's been conjectured.
Yeah, it's really super small. It's just a small number. It's not a small size. It's just a small number. So and computers can't even handle numbers that small. Computers only have 17.
Correct.
They only have 17 digits of precision. So the computers have to do tricks to represent numbers that small. And then you lose digits of precision when you try to do math at that scale.
Have you seen the proposal for the trinary bits? Have you seen that proposal yet?
Trinary bits? Oh, for quantum mechanics?
No, not necessarily, but I imagine that they could utilize it in quantum computing.
Okay.
Yeah, it's a pretty new. There's a lot of really interesting things happening in computing.
There's some really cool stuff happening. There's lots of stuff happening with the low energy nuclear reactors. I don't know if you're following that.
Leonard,
Yeah, Leonard. Yeah, I'm actually on an email group with Bob Greener. You know Bob Greener?
Martin Fleischmann.
Yeah, the Martin Fleischmann Memorial Project. So I'm friends with him now, and we're in contact. And he keeps, I'm sort of the fly on the wall watching, his project, and I get privy to some information.
He's got lots of flies on the wall, hon.
Yeah, for sure. Yes, definitely. And so he's a really nice guy. He's such a good guy. So
he's a nice guy. I spoke with him on my phone. Well,
good.
In Toronto, but I couldn't.
You went to? Oh, you talked to him in Toronto. I go. If it wasn't for the frickin' storm, I would have. I'm in London, Ontario. So yeah, you know that. So that's good that you at least got to talk to him. I
was trying to make arrangements. I was telling them that like on Saturday night or Saturday evening, I tried to get a hold of him and his wife and blah blah blah, and then he called me back at around 8 o'clock. I said, "Hey, if you want,
excellent.
I'll come downtown. I'll drive you around the city. take a drive and do whatever, you know, stop here, stop there. But he said, oh, I'm on whatchamacallit time, European time. Oh, he's ready to go to bed right now, right?
Yeah. So so he actually, there's some pictures that he showed that I showed in my videos actually from the experiments that they're doing. There's this thing that he sees, which are these vortex anti-vortex pairs that is like it's got a hill and a valley, right? I don't know if you've seen those, but anyways, there's something that he sees in his experiments that matches that I can match to my model.
Mini Birkeland currents is what. Vortex and anti-vortex, that's a Birkeland current.
Yeah. Current, right?
It is a spinning structure of how a Birkeland, how the energy moves in a Birkeland current.
Do me a favor, let me hear all of her ideas there.
Yeah,
and then we'll open it up for more debate. Yeah.
Okay. So what did you want to hear?
You were going along the lines. You were talking about vortexes and anti-vortexes.
Oh yeah. So my model is of particles and people get triggered when I say the word particle. But anyways, my model of an electron, let's say, is a spinning vortex anti-vortex pair. And if you take a spinning anti-vortex pair and move it through space, it's going to create a Birkeland current. It's going to create the double helix Birkeland current. Right, so Birkeland currents kind of come out of my model as well. So I think they're amazing, actually. I think that, you know, I mean, we see them in nature. So in the double helix of the DNA, and you see that everywhere. So yeah.
What happens when you spin something? When something's spinning and you move it, it creates a spiral.
Yeah, exactly.
Yeah.
It's a double helix. If you have two charges, so my model, you have two, I'm going to call them charges just for the sake of a word. You have two charges that are spinning about a central, it's like a binary system, right? About a central point. You can see it in your head probably. You see two charges that are spinning. Think of the yin yang. I use the yin yang actually as my schematic for my model because it's just such a beautiful image.
One second. I hate to do this to you, but I'm just gonna improve you. Trust me.
Yeah.
You will be appreciated. Yin, yin, yang.
What?
Yin, as in
yin,
yang. No G. Yin, yang.
I know, but I can't. I have to say it the way I always say it.
Okay, you can say also yin, yang.
Yin yang. That's easier to say. I always say yin yang. I don't know why.
Yeah, I'm
Canadian. I say I say yin yang. I don't know.
Yeah,
it's an English bastardization.
You are right, though. I should say it more accurately. I should say it more.
I'm Chinese sciences as well.
So imagine a yin yang spinning, because it looks like it's spinning. The yin yang looks like it's spinning. If you spin that and move it through space, you can see that it's going to create a double helix. Right? It's going to create a double helix spiral through space if you could do that.
Yep.
So that's, that seems pretty obvious, but that, so that is the model. So my model of the electron is a yin yang, and my model of a proton is a yin yang, and they're just at different scales. This is a scalable model. So yin yang doesn't have any scale. It could be giant, it could be small. But when you do that, I use the Compton wavelength as the circumference of my model, and I use the Compton frequency as the spinning frequency of the model. And when you do that, the tangential velocity of the outer edge of the model of the yin-yang is the speed of light, right? So what I say is that light is a wave that propagates through space, and matter is a wave that propagates in place. So it's a standing wave, a wave that's standing in space, not propagating. So that's the only difference between matter and light in my model, is that one is standing still and one is, unless you try to move it, but naturally the rest, it's at rest in your frame of reference, and light is moving always. So light propagates in space and matter propagates in place. So saying it that way makes, brings them, sort of unifies them a little bit, because they're both waves. One is a standing wave, but not the traditional standing wave of that you imagine of just like sitting there. It's doing something, it's propagating, and it's propagating at the speed of light, because the tangential velocity is the speed of light. But and so the proton has a higher frequency, but it's smaller, and the electron has a slower frequency, but its Compton radius is bigger. So the electron is actually bigger than the proton in my model, right? So, but it's scalable. So there could be other particles, and the lighter the particle, the bigger the Compton wavelength, basically. So as this thing is spinning, so the more times it spins per second, the more massive we perceive it is. So the proton is more massive than the electron. It's bigger in mass because it spins faster, but it has to be like its Compton wavelength has to shrink. Kind of like the skater, when the skater is spinning and she or he has to pull the arms in to spin faster and faster and faster. That's the analogy. So the heavier particles are smaller, and we know that's true because we know the heavy particles in in the periodic table are smaller than in terms of the space that it takes up in terms compared to the hydrogen atom, let's say. So it's a good model. It's very easy to understand. I think it's accessible. It's very self-consistent. So there's no things like the alpha, the fine structure constant goes away when you use my model. Anomalous magnetic moment goes away when you use my model. It's a calibration issue. So they as in historically mainstream physicists, calibrated charge wrong, right? Planck charge is nature's charge. So elementary charge is not elementary, right? And so wherever you see the fine structure constant or wherever you see anomalous magnetic moment in an equation, it's a calibration error. It's a calibration error, in my opinion. So that was another one of my big revelations, breakthroughs that I had over the last couple of years. So anyways, it's exciting.
Well, no, it's nice to hear from you. And I also had another question. Are you still involved in the Distinti community?
Am I still involved with?
Robert Distinti's community.
I still keep up with his work, but I'm not. I stopped being a Patreon because he just wasn't moving fast enough for my liking.
Yeah, me too.
But I have to give him credit for two things. I got my idea for complex numbers from him, yes, or at least starting point for it as a 2x2 matrix. So yes, my implementation of complex numbers as 2x2 matrix and quaternions as 4x4 matrix started with him. He gave me a couple of clues that gave me a breakthrough, right? So he doesn't necessarily do it this way, but he gave me the clue as to how to model the imaginary number as the backward diagonal of a 2x2 matrix, and that was brilliant.
It is brilliant. He deserves a prize for that.
He really does deserve a prize for that. I mean, he didn't invent it, because I actually went back and they do it, but they bury it. So if you look at complex numbers, they bury the 2x2 matrix formalism. He didn't invent it, but he reinvented it. That
we do in engineering, but
he reinvented it, which is really great. And the other thing I got from him, actually, my model was based on. So he's got his pretons, right? Was based on his preton. Only I use the Compton wavelength, and he uses the classical electron radius. And that's where the alpha correction comes in. When you do this correction, this calibration correction that I'm talking about, you end up in the domain of the Compton wavelength. And when you switch to the Compton wavelength, all the problems go away. Everything is like, oh, this is so simple. How come no one ever thought of it before, right? So it's sometimes the numerology, sometimes, you know, like the mainstream physics and maybe even Robert Stinty, I don't know, are obsessed with radius. And so what I do with my work is I in radian. So all of physics is done in radians, all of, you know, angular frequency and angular momentum and everything. That's all.
Are you using spherical coordinates as well?
And so I switched to cycles. So a radian is not fundamental. A radian is just a part of a circle. So one radian is just a part of a circle. What I did was I eliminated everything except for cycle. So a cycle is a complete circle, right? One cycle is a complete, you know, one complete wavelength, one complete time, you know, turn around the circle. And so basically what I'm very strict with the physics I do, and I said, okay, I'm not going to allow radian. I'm gonna switch to the domain of the frequency, which is cycles per second, instead of angular frequency, which is radians per second. A radian is nothing. A cycle is something. So I got rid of radians. And I do everything in terms of the complete cycle, which is, you know, I believe nature is quantized by the cycle, not by the radian. So that fixed a lot of bugs. And then everything came out. I'm like, oh.
I would assume the law of rotation agrees with you. So the question I asked is, did you switch to spherical coordinates, or are you still using Cartesian coordinates, or are you using cylindrical coordinates?
Switch back. I'm a computer scientist, so I constantly switch back and forth from spherical coordinates to, eventually I have to plot the point on the screen. So at some point I have to switch to, I have to put an XY somewhere on the screen. Spherical coordinates and Cartesian coordinates are just two different ways of representing the same thing. Correct. So basically,
but they do inform how you think, though.
It does. So I start with spherical coordinates until I need to plot the point. Then I use x equals cos theta, y equals sine theta to find the location on the screen. So, but people forget that they put too much emphasis on the coordinate system, XY coordinate system, and they forget that, you know, the universe is spinning, everything is spinning, and you got to do everything in cycles. Everything is in cycles. And so the only difference with the radians, everyone does things in radians. I'm not sure why, but you know, you need radians. If I want to measure an angle in a circle, I need radians. But when you do physics, if you want to quantize something, you have to do it in complete cycles. You can't do it in radians. If you think the radian is the universe is quantized by the radian, then you're experiencing wrong thinking. The universe is not quantized by the radian. It is quantized by the cycle.
Well, all of the 8 laws are they're all coeval. They're all happening at the same time. So the law of vibration and the law of is feeding directly into the law of rotation, and then there's of course backfeed. What's interesting is the law of vibration is sitting opposite of causality, and then rotation is sitting between vibration and polarity. Polarity is sitting opposite of relativity. And conservation is in the mix, also informing everything. And of course, then you have flux or evolution, whatever you want to call it, and you have resonance. So all of these are happening at the same time, and of course, they're all completing in one cycle. And there's really no time for that. It would be impossible for us to actually measure how quickly that's happening because it's basically instant. Yeah.
So the one thing that I do that also helped me sort through all this stuff is I switched to the domain of frequency. So I only ever talk about vibration frequency. I only allow frequency to be in the equation, right?
You're a law of vibration person. Okay.
Correct. And so if someone says wavelength, I immediately convert to frequency. Okay. If someone gives me a problem with a wavelength in it, the first thing I do is switch to frequency.
Is that a philosophical choice? Is that part of your philosophy?
Oh no, it's an important choice because Nikola Tesla said if you want to understand the universe, you have to think in terms of frequency, vibration, energy, frequency, and vibration. So he understood this. He understood that the wavelength is just an expression of frequency, and so if you do everything in frequency, if you talk in terms of frequency, then things become much easier.
Well, it's
I
certainly
didn't
a
want
lot
to.
easier
I didn't want to jump in right away, but I was going to say Tesla. As soon as she started talking about she switches right to frequency,
Right.
I was just going to say Tesla.
Yeah.
Well, it's
That's-
certainly a lot
I'm just
easier to
following.
figure out.
I'm just following his advice.
It's certainly a lot easier to figure out how to use the law of resonance if you know what the frequency
Exactly.
you're working with. Yeah.
Yeah, and if you look at the atom, it's a resonance, right? So if you look at all the energy levels of the atom, they are all based on resonance frequencies. They're not like they don't jump.
Well, and dissonances, because things do have to be different too. But there's resonances and dissonances.
Oh, no. Yeah, resonance can be constructive or destructive.
Right.
Interference. So
Exactly.
Yeah. Yeah.
Well, good. You got a good head on your shoulders, that's for sure.
Thank you.
Now, speaking of the thinking in terms of one coordinates, Jonathan, who is listening in, posted an article of this guy, and I found it really fascinating because he was clearly a brilliant guy. But the more I listened to him, the more I became convinced that the man saw and thought in terms of spherical coordinates.
Okay.
That he was seeing, and so he was seeing the universe and the bending of the magnetic fields through what you radians, whatever you want to call it, through wavelengths, and that his mind was actually seeing it in that way, which is different than most people typically think in a Cartesian manner. Yeah, it was interesting, and I was curious as to whether or not that was true for yourself or not. I also agree with you about the 2x2 thing. They do teach that, but they teach the bastardized version, which is the heavy side stuff.
Right.
And which is fine because it works when you need it. But I think Distinti is unique in his definition of the imaginary number in that way. I have not found any other. If you find evidence of that, send it to me.
Evidence of what?
That somebody else had the same imaginary number.
If you
matrix.
If you look up,
which I think is 0, 1, -1, and 0.
If you look up co-quaternions, if you look up, go on Wikipedia and look up co-quaternions, you're going to see that they identify I, the imaginary unit, with the backward diagonal of a 2x2 matrix. That's the only place I've ever seen it officially on Wikipedia.
Oh, there you go. Yep. Boom. There it is. It's right there.
Yeah.
You know what year? Okay, here we go. It says introduced 1843. Well, look at that. So he rediscovered it. God bless the man. He put so much brain power into everything he does.
For sure.
I liked his Vortrix work, and I liked this work, and I liked his new electromagnetism. I'm not big on the Preton work, I'll be honest with you.
Well, the Preton work is, I think, like my model is very similar to his Preton model. So I have to say that, it's okay. I think he just has his numbers wrong. He's using classical electron radius, and I use the Compton wavelength. That's the only difference, really. I think he's really onto something there. So I hope
is your intent to propose a mechanism where we would actually get the anatomy of the ether and of the counter space? Is that the long-term goal?
I do have if you do a search for a paper that I wrote called A Medium for the Propagation of Light Revisited by Laurie Gardi. I wrote a paper on what I believe the ether is made of. It's electron-positron pairs, basically. So it's pretty simple. I don't, So and when you do the math, you can see that
the SAM guys.
It creates the right propagation rate, the speed of light. So
you know about the structured atomic model, right?
Of what?
The structured atomic model. You know about that, don't you?
Yeah. The structure, what?
Yeah. The Rick, why don't you explain?
Well, SAM, it's for short. SAM, the structured atomic model by Ido Cal and his gang of.
They've been at it since what, 2010 or something? I don't know how long.
Yeah, somewhere around there.
Okay, I think I've heard of it, but
yeah, go ahead and explain.
Go to hang on a second.
SAM.org, I think.
No, it's
but explain the whole premise of the nucleus.
Well, the way they build
is it structured atom.org?
No.
There's SAM, structured
ethereal matters.
Ethereal matters also.
No, it is structured atomic model SAM.
Oh, okay.
It's structured atom.org.
They have actual
geometry.
Yes, and they have actual I guess, element to a periodic table that they're constructing using the electron-positron pairing nucleus.
Okay. Oh,
Yeah.
there you go. So I will have to look it up. Thank you. That's
Yeah,
a
no
good-
problem. I didn't know that.
That you didn't know about
I can't.
that.
I don't have
It's
time to follow
amazing.
everything.
Right. Well, but that's the one of the reasons why we do things in
This
the Pulse.
show
We
and
have the
other-
gateway, right? Well, the
Good.
gateway, we have an entire. And you know what? Now I think about it, I don't think I've created a page for you yet on the gateway. I probably need to do that. Yeah, I have not. So I need to create. I'll get some stuff. I'll get some of your stuff embedded. Where do most of your shows happen? Do they happen on
Well, if you go to YouTube and Fractal Woman.
Fractal Woman? All right,
obviously
right. Fractal
you'll
Woman.
find my
Yeah.
channel, so you can link that in if you want.
Yeah. That's what
probably
we'll
the
do.
best. Is
I'll have your top papers on there and stuff. Yeah, so that's good because you're already thinking in alignment with this new plasma electronic cosmology that's happening. These guys have been at the SAM for at least 10 years. I don't know exactly when they got started, and they have mapped out a whole bunch of atoms based on the properties. They rearranged the isotopes, and they've figured out that the isotopes are essentially just building blocks that are getting repeated, and it's all based on geometry. So that there's nothing arbitrary. There's no plum pudding essentially of the nucleus.
Nice.
And there's no need for a neutron because essentially a strong force is just that
It's
these two are
basically a
even
neutron
closer
proton
together.
pair.
Right, exactly.
Okay.
They're
Or
even closer
an
together.
electron, sorry.
Great.
So same force, just tighter, tighter distance. So hence the extra order of magnitude and strength.
Great.
So wow. So you're on line with what else are you getting to?
For sure. I mean, that's what tells me that I'm on the right track. If I'm in line with the other people that are,
Searching.
yeah. So when the pieces of the puzzle start coming together really quickly, then the puzzle's almost done. You know what I mean? Like when you make a puzzle and at the beginning you just group things that have similar color and you don't know where the pieces go, and then towards the end of the puzzle everything just sort of starts fitting in. That's sort of where I am right now. Things are really, really fitting in, and so I know what's correct if it fits my model. If I see the beauty in what someone else is saying, and you know what I mean. So yeah. Anyways, I gotta go here, but I just want
that was
to
a good. That was a good short thing. People will get to know a little bit about Lori, and
Good.
I'll be able to make sites. Good. Pop in more often.
I will. Thanks.
A
Yeah,
little
you're
mini
welcome.
interview of Lori.
That is 30 minutes of powerful stuff.
Nice. Cool.
All right.
All right. You guys have a great day.
Thank
Take
you.
care,
You too.
Lori.
Okay, bye.
Bye-bye.
The geometric view is a love is watching product. Love is watching being. Thank you for doing that. Keep your eyeballs out. Pay attention. There's a lot going down this year. Be vigilant. Be mindful. Be insightful. Be loving. Thank you for being here. Thank you for being kind. Share the love. Spread the love. Become the love. Amen.
The grimiest and the grittiest of life, I'm there. Through the grimiest and the grittiest of life, I'm there.
all over the wall, eyes all over your body. And I can see straight through with transparent golden scaling. The largest of the atoms embark on this because this is the journey. The journey is life. Take hold. Here we go. 3, 2, 1. I'm Join us in the fight for Christ, in the fight to save lives. Surprise, submersible, so fast, the first, the last of baptism, need to say more. Pay attention like the marrow in your bones, arrow in your back, arrow in your lungs, zero into the back, tertiary Christian neuron, synapses and narrow endurance into eternity. I'm a courier, a charismatic attitude, modern meters even neater, it might even be fun. Cider indeed, need nerds, you need nerds, need a virtue, need to be a reason. Feasibility to be a reason to be clean and sober, keys, open doors, signs of directions. Be the carrier of candlesticks, the Mandelbrot you change. Every second you ride, to make a ribbon, you pivot, but touching your curving cat. Could be cold, could be copycat, could be copy corpse, could be Schrodinger's best. Could be micro-hacker, Mackie, normal, open-minded, itsy-bitsy, freaking huge, a universal supermassive aspect of attached awareness. Aware of this all?
Collaborative consumption.
Are you aware of this all?
Collaborative consumption. The new thing consumption. Collaborative consumption. Consumption.
Get up now! Out of the boat! Drop! Where did this up? We don't got about a girl, but about a not about a goddess spirit. Get up, what's up? Get out, chapter. Little butter.
I'm in search of, I'm in earth love, I'm in living life, I'm in living color, I'm in air drop, I'm in earth thing, I'm in earth thing, I'm in earth thing, I'm in earth thing.
Never give up, never give up, never give up, never give up.